Hi, this is Additional Mathematics Form 5, textbook chapter 3, formative exercise 3.2. Okay, so let's go straight to this. The first question, you're supposed to find indefinite integral for each of the following. So you need to know and remember the techniques of integration. There are actually 5 of them. So the first one is when you integrate a constant k, you get kx plus c. I'd like to go through this formula with you. Right, so this is just kx plus c. So for part A, when you integrate 1 over 2 dx, you just get 1 over 2x plus c. Okay, now the second formula is integration axn dx. So when you integrate this, we copy a, copy x, increase the power by 1, divide by the increased power plus c. Alright, so this is what we call the general term. Yeah, okay, now but in the event that you have x below, right, so I know some teachers will tell you bring the power up, change the general form, integrate, and then bring it back down, but that method is very slow, right? I can show you here, right? You can bring this up 5 over 3 x power negative 3 dx. Okay, this is part B. This is the first step. Second step, when you integrate, you copy the your a 5 over 3, copy x, increase the power by 1, minus 2, divide by the increased power, and then you put plus c. Okay, maybe I should put a bracket here. And now when I bring this down, it's 5 over 6x squared plus c. Now personally, I like to use this method, and I always teach my students to use this because it's faster. You can do it in one step. You put a negative in front, copy a, copy x. Now instead of increasing the power, we reduce the power by 1, put the reduced power in front, plus c. Right, so it's way faster, right? So maybe I show you here. Now if I want to integrate this, I see this is 5 over 3x cubed dx. So you put a negative in front, copy 5, right? Copy a 3, copy x. Now instead of increasing the power, we reduce the power by 1, put the reduced power in front, plus c. So this is negative 5 over 6x squared plus c. Notice you get the same answer regardless whether you use method 1 or method 2, as in the general form, or what we call this a reciprocal form. Now, however, I don't use this reciprocal form all the time. It depends on the question. In the event that your x, if your x is below and he has power fraction less than 1, so I would prefer to bring it up. Okay, as in this question, right? I'll prefer to bring it up. I think it's easier if I bring it up, right? In the event that you have power less than 1, for example, power negative half, so I bring it up. So you increase the power by 1, negative half plus 1 is just half, divide by the increased power plus c. When you bring this up, you get 2 root x plus c. Now you can also use this method. Yeah, let me show you. Put a negative in front, copy 1 over x, reduce the power by 1, put the reduced power in front, plus c. So for me, I think a lot of students will find this a little bit confusing because of the double negative, right? And you still have to switch this up. When you bring this up, this is 2. Power negative half, when I bring up, becomes power positive half. And power half is just square root. So 2 different methods, same result. Okay, now for D, I'm just going to use the reciprocal formula because this is quite clear-cut, quite easy. I put a negative in front, right? Copy 2, copy x, reduce the power by 1, 2, put the 2 in front. The second one, when I put a negative in front, remember the formula has a negative in front, so you got to put a negative in front, so it automatically becomes positive because originally I have a negative here. Copy 3, copy x, reduce the power by 1, 3, put the 3 in front, plus c. Now notice I can simplify this, I can cancel them, so it's negative 1 over x squared and 1 over x cubed plus c. Okay, so this is question number 1. So let's move on to question number 2. So here we have to integrate one by one. So the first one, I would split this first. So you can't integrate directly. And remember, you have to integrate. Before you integrate, you're going to change your general form. Yeah, either axn or k or a over x power n. Yeah, in the event that x is below. So I'm going to break this up. This is 5x squared divided by x is just 5x. 3x cubed divided by x. When you divide the x, you're left with 3x squared. Right? Just cancel them straight away. And when I integrate, copy 5, copy x, increase the power by 1, divide by the increased power. Second one, copy 3, copy x, increase the power by 1, divide by the increased power. This is the case where the x is below the axn, so you're supposed to increase the power. Now, if you can simplify, we simplify them. So in this case, I get negative x cubed here. Can you see that? Plus c. All right. B. Same thing. We can simplify for 6 and 2. You divide, left with 3. X cubed, divide by x squared, you're left with x. 2x squared and 2x squared you can cancel, left with just 1. So when you integrate 3x, you get 3x, increase the power by 1. This is 1, increase by 1 becomes 2 over 2. Now 1 is a constant. When you integrate 1, you get 1x. We just write x plus c. Now, part C, I have to use the composite function. Even composite function, there are two types. Okay, I'm just going to write this for you, the formula. So take note, composite function, unlike differentiation. Differentiation, we can have any function inside. Can be a quadratic, cubic, linear, reciprocal, whatever function inside the bracket. But for integration, whatever inside the bracket here must be linear. So we copy the bracket, you increase the power by 1, divide by the increased power, and you differentiate inside, right? So that is the formula. So here I integrate 5 minus 6x power 3 dx. I copy my bracket, increase the power by 1, divide by increased power, differentiate inside. So this is negative. Now you can put 1 over 24. If you want to divide by 24 also can. 5 minus 6x power 4 plus c. Okay? Now for part D, right, there are two ways to look at it. Now, you can use this shortcut, the reciprocal form. So I like to call this formula number 5. Put the negative in front, copy k, copy ax plus b, reduce the power by 1, put the reduced power in front. One extra step, that is, you got to differentiate inside the bracket. Now, but in the event that your x, right, you notice the power here is smaller. This is power 1 over 4. So maybe it's better to use the general form here, to use this first formula rather than second formula, yeah, in the event that your n is small, less than 1, okay? Now, so I'm going to bring it up, right? So, but you want to use the second formula also can, you get the same outcome. So let's take the bracket, increase the power by 1, negative 1 over 4 plus 1 is 3 over 4, divide by 3 over 4, differentiate inside the bracket, I get negative 2. Now I can cancel this and flip it up. Now this one, when you cancel, you're left with 2. So when you flip it upside down, it's going to be negative 2 over 3 with a 5 minus 2x power 3 over 4 plus c. Okay? Okay, let's move on to question number 3. In question number 3, you're given dy dx, okay? And dy dx is 20.5 when y is 19, x equals to 2. So if you want to find p, right, to find the value of p, we should sub in your dy dx, okay, with 20.5 and your x with 2, yeah, to find your p. So this is 20.5, this is 20, this is p over 4. 20.5 minus 20 is just half, right? So if I times over half times 4, p is just 2. Now, subsequently find the value y when x is minus 2. So we know our dy dx is now 10x plus 2 over x squared. To find y in terms of x, I have to integrate. Integrate your dy dx, you get your y. So this will be what? 10x squared over 2. Negative in front, copy 2, copy x, reduce the power by 1, 1 plus c. You don't have to write a 1. Your y is 5x squared minus 2 over x plus c. Now, we have to first sub in your y with 19 when your x is 2, correct? To find the value of c. So 2 squared is 4. 4 times 5 is 20. 20 minus 1. Oh, this is exactly 19. So my c is 0. Therefore, my y is 5x squared minus 2 over x. And we're finding the value of y when x is minus 2. So you square it, divide it. So it's 20 plus 1. My y value will be 21. Okay? All right, I think this is not that difficult, right? Okay, let's move on to question number 4. Now, here you're given part A, dy dx equals to 4x cubed minus 15x squared plus 6. Okay, so we need to integrate 4x cubed, 15x squared plus 6 dx. So when you integrate, copy 4, copy x, increase the power by 1, 4 over 4. This is 15x 3 over 3. Integrate 6, 6 is the constant, you get 6x plus c. Now I think we can simplify. This is x power 4. This is 5x power 3. This is just 6x. Now it is given that your y is negative 20 when your x is 3. So let's put this inside. This is 3 power 4. This is 3 power 3. 6 times 3 plus c. Now you want to use a calculator. 3 power 4 is 81. 3 power 3 is 27. 27 times 5 is 135. This is 18, right? Now, this is negative 20 equals negative 36 plus c. C is just 16. So now I know my equations now. X power 4 minus 5x cubed plus 6x plus 16. And to find the value of y when x is minus 2, we'll just put minus 2 inside. Yeah? So this is 5 minus 2 power 3, 6 minus 2 plus 16. This is positive 16. Negative 8 times 5, 40. This is a plus because negative 8. Minus 12 plus 16. Answer is just 60. Okay. Okay, next, let's look at B. The dy dx is given. Again, we integrate our dy dx to get our y. In this case, it's x squared plus 2x plus c. Right? Now, this is easier than part A. You're supposed to find c first. Let's sub in when y is 2, x is 2. Alright, so 2 equals to 4 plus 4, 8. C, 2 minus 6. 2 minus 8, negative 6. Now, so my y is now x squared plus 2x minus 6. To find the value of x when y is negative 6, just substitute here. X squared plus 2x minus 6. Now notice you can cancel the 6. Yeah, negative 6 and negative 6. Factorize. And x is either 0 or minus 2. Okay. Moving on to question number 5. So here you're given equation, you're given a curve, and you're given your gradient function. Gradient function is basically dy dx. To find equation and curve of y, we have to integrate your gradient function. So as I integrate this, I get x power 3 divided by 3. Okay, I'm just going to show you one by one, step by step, just to help you understand. Yeah, I hope that you already know how to integrate quickly. So, so you can cancel 3 and 3, cancel 8 and 2. Now I need to find the value of c. So we need a point on the graph, and you can see point A is given. So your A is negative 1, 1. That means my y is negative 1 when my x is 1, right? So minus 1 is minus 3 plus c. C is just 2. So my equation of the curve is just this. Okay, so that is question number 5. Moving on to question number 6. Okay, now it is given a gradient normal of a curve at one point is this 1 over 6x minus 2. Now remember, gradient of tangent is your dy dx. So if you want to find your gradient normal, your gradient tangent or dy dx, you multiply by gradient normal. The result must be negative 1. Yeah, dy dx is your gradient of tangent. So your dy dx will be, if I multiply over, I get 2 minus 6x. So to find y, I have to integrate. Yeah, so when I integrate 2, I get 2x. Integrate 6x, I get 6x squared over 2 plus c. You can cancel or simplify this. Okay, to find the value of c, I'm going to sub in 2, y is 2 when x is 2. So this is 4 minus 12, which is negative 8, right? If you bring over c is just 10. So your equation of the curve is therefore 2x minus 3x squared plus c. My c is 10, so just sub in. Yeah, sub back the c. Sorry, I should draw here, inside here. Yeah, okay. Okay, question number 7. Sorry. Now, in this question, your given gradient function is ax plus b. The gradient at the curve minus 2, 8 is minus 7. So we know that your dy dx is ax plus b. When x is negative 2, my gradient of a curve means gradient of tangent is negative 7. So you want to put negative 7 inside. So up to you who you want to make as a subject. So you can actually leave it out first. So I'm just going to write b minus 2a equals to negative 7. Okay, just leave it out first. Okay, now at the same time, there's another coordinate given. When x is 0, your dy dx is 5. So again, I sub inside dy dx is 5 when x is 0. And here you can find b. B is just 5. So when you sub inside equation number 1, b is already 5. You're finding a, right? So you bring this over, negative 12, a is just 6. Yeah, so you got the value of b and the value of a. Now, then to find equation of curve, first of all, I'm just going to sub inside here. My a is now 6, my b is now 5. So my dy dx is 6x plus 5. To find equation of curve, I need to integrate 6x plus 5, right? So this will be 3x squared. Okay, I tend to want to do faster. I hope you can do this faster. 6x squared over 2, so it's 3x squared plus 5x plus c. And to find the value of c, we have to sub in any point. Now, I think between these 2 points, obviously it's easier if you take the one with 0, right? Your y is 6 when your x is 0. So 0 times anything is still going to be 0. My c is going to be 6. My y is 3x squared plus 5x plus 6. Okay? So that is question number 7. And the last one, question number 8. Okay, this is involving displacement function of a car. Now they say the rate of change ds dt is tan t minus 2. So you're supposed to find the displacement when t equals to 3. So it's about the same as what we've done, just that this is more application oriented, yeah, related to displacement. So you need to integrate this. This is tan t squared over 2. Guys, again, can I write this? This is tan t squared over 2. I just write 5. When you integrate 2, it's just 2t. Remember, if you differentiate, when you integrate respect to x, like integrate 2 dx, we just put 2x. If you integrate respect to t, just put 2t. Yeah, just change the unknown or the variable. All right, to find the value of c, we need to use this information. When s is 8, t is 1. S is 8, t is 1. So this is 3. Bring over c is just 5. So my displacement function is 5t squared minus 2t plus 5. Okay? And to find the displacement when t is 3, just substitute inside 5, 3 squared minus 2 times 3 plus 5. So this is 9. 9 times 5 is 45 minus 6 plus 5. So 45 minus 1, 44 meter. Okay. Yeah, that's all for this formative exercise 2.2. Thank you for watching.